All right. Well, this is a little activity I like to call the fireworks lab, and it goes with what the notes were concerning the idea of how the electrons jump back and forth and give off specific wavelengths. Now, I know it's in the dark right now, but that's because what we're going to do is we're going to burn some different metals, and we're going to see what kind of colors they produce. So the first thing I want to show you for chemistry is how to light a lab burner. Okay. So what you do is you light the match first, hold that over the Bunsen burner, then turn on the gas. So as soon as the gas comes out, it ignites. The other thing I also like to show is where is the hottest part of the flame. Most people think the hottest part of the flame is down here at the bottom of it. What I have in my hand is a match that I just took out of the matchbook, and watch if I run it through the flame down here. Oops, and it did actually light. That's one of the first times I ever had that happen. It got warm enough. So try it again, and I lit again. Man, usually it doesn't light for me way down there. So if I go through, all right, and I go up here at the same speed. I know that you're going to go, well, man, you went too fast down at the bottom. But if you notice, I go the same speed at the top, and at the very top, it lights right off the bat as soon as you go through. Okay, so this part up here is the hottest part of the flame. Why is that the hottest part of the flame? Because that's when it's actually burnt the fuel. Down here, it's just starting to burn it, so it hasn't gotten all the energy out of it yet. So the reason why I'm showing you that is because this is where I'm going to put the metals, is up here at the top. And what we're looking for is we're looking for a change in the color of the flame. Okay? So the first one we're going to do is I'm going to do strontium. This is element SR, strontium, and I'm going to put it inside the flame. And it takes a second, but if you watch, you can see that it becomes kind of a reddish color. There it is. There's the red color. So that's just basically all it is it's the electrons in the strontium jumping down, and as they jump back, they give off a specific wavelength, and that specific wavelength falls into the red part of the spectrum. All right, I'll do potassium next. Strontium, by the way, that's my favorite color. Potassium, element K. It takes a couple seconds in order to get those electrons to jump. There it is. If you notice in this one, we kind of get like a purplish color at the top. So there's kind of a little purple tint to it. And I know going through the video, it may not be perfect, but some of the yellow, what it is it's my Q-tip burning too. So we are going to have some yellow that pops up too. This is copper. This is one that you commonly see in bonfires because it's a real cheap one to get a hold of. Again, takes a second to get it starting to burn. There it goes. And this one, you should see it's turning the colors, it's turning into green. So we end up with a green color to the flames. Besides the yellow of the Q-tip burning, but we do have some green inside there, which is the copper burning. Now, the next one's a really strong color. This is sodium, which happens to just be table salt. There we go, there's table salt. It's a lot of orange and red, orangish red, a lot of orange really. That's a really strong color. So you can see that's one of the strongest colors we've had so far. So. All right, then we got cobalt. These last two don't burn quite as brilliant as the other ones, but there we go. It's kind of got a little purplish color to it and some orange color to it. All right, so it's got somewhat like a sodium, but it's also got a little bit of like the color that we had for potassium. And my last one to show you, which is calcium. There we go. It's a little darker orange than what we had for the sodium. a little bit more towards the red end of the orange spectrum. Not quite so much red, or not quite so much orange like we had with the sodium. All right, so that gives you some of the colors that can be produced. So again, what it is that when you go to a fireworks display, those different colors that you see at the fireworks display, those are different metals that they're burning, and that's why we end up with the different colors. So we'll see you next time. Have a great day.